In this segment, we're going to be looking at how to find all x-intercepts or roots for a polynomial function. So we're going to work with this function for our example. F of x equals 2x to the fourth plus 3x cubed minus 11x squared minus 24x minus 12. Our first step is going to be to list the possible rational roots. And we did that in the last segment. So the possible rational roots for this function, we want to list factors of the constant term, so factors of 12, plus or minus 1 and 12, plus or minus 2 and 6, plus or minus 3 and 4, over factors of the leading coefficient, which is 2, so plus or minus 1 and plus or minus 2. Then we want to split the list, so our possible roots will be 1 over 1, so plus or minus 1, 2 over 1, plus or minus 2, 3 over 1, 4 over 1, 6 over 1, and 12 over 1. And then 1 over 2, 2 over 2 would be the same as 1, 3 over 2, 4 over 2 is the same as 2, 6 over 2 is the same as 3, and 12 over 2 is the same as 6. So we have 2, 4, 6, 8, 10, 12, 14, 16 possibilities. Then the next thing we're going to do, step 2, is we are going to test the possible roots until we find one that is an actual root. And the way that we're going to do that is to use synthetic division. Remember that if the remainder equals 0, then it is a root. So let's go through some testing. Let's test 1. We'll just kind of start somewhere, and it doesn't really matter where you start, and it doesn't matter if you test the same values as someone else. So we put 1 in a box, and then we're going to list our coefficients: 2, 3, negative 1, negative 24, negative 12. Make sure that if you have any gaps, like that, you use that placeholder of 0 for any missing terms. Okay, so we'll test this. Bring the 2 straight down, multiply times 1, add, multiply, add, multiply, add, multiply. And I can add this, or I don't have to add it. I get negative 42, which means it's not a root. But it is kind of important to note that the ordered pair 1, negative 42 is on the graph. So we'll move on to another value to test, maybe negative 1. So I'll do the same thing again. So bring down the 2, multiply times negative 1, add, multiply, add, multiply, add, multiply, and add. Okay, we found a remainder of 0. So it is a root. So that means we have an x-intercept at negative 1, 0. So what we're going to do then is that we will kind of add that to our list of roots. Let me grab something real quick. We'll use a post-it note to list our actual roots of our equation. Roots. We found the first one is -1. I'll keep that off to the side. Once we have found a root, what we're going to do is we are going to rewrite the function as a product of the divisor times the quotient. So we will write f of x equals the divisor times the quotient. Okay. Now, just a reminder on that if x equals -1 is our root, then the factor or divisor is going to be, we add 1 over x plus 1. Okay, so I will rewrite f of x is going to be the divisor of x plus 1 times the quotient. Remember, in your quotient, you have your constant term, your x term, your x squared term, and your x cubed term. So that will be 2x cubed plus x squared minus 12x minus 12. Let's go back and look at our original function. This function was 2x to the 4th plus 3x cubed minus 11x squared minus 24x minus 12. Notice that the degree of our function is 4, so that means we need to find how many roots. If the degree is 4, then that means we need to find 4 roots. Okay, so we found 1, so we've got 3 more to go. Now notice that after we divided out our x plus 1, we had 2x cubed plus x squared minus 12x minus 12 left. So what we need to do is we need to actually keep testing those roots, but it doesn't make sense to test from the original function. What we want to do for our next step is we are going to repeat steps 1 through 3 using the quotient. So don't go back and reuse the original function. We're just going to use the quotient to keep kind of breaking down our function. And we're going to keep repeating that until the quotient is quadratic. Quadratic, remember, means a degree of 2. Once the quotient is quadratic, then we won't break it down using synthetic division anymore. Then we will use the quadratic formula to break it down, or factoring to find the last 2 roots. Okay, so we're going to go back and repeat steps 1 through 3. So now our function is broken down into x plus 1 times 2x cubed plus x squared minus 12x minus 12. So step 1 was to list the possible roots. So this time we are using this part of our function for our possible roots. So the possible roots will be factors of the constant term, so plus or minus 1, 2, 3, 4, 6, and 12 over factors of the leading coefficient, which is 2, so plus or minus 1, and plus or minus 2. Now this list should look familiar because we have the exact same list that we started with. So we'll have plus or minus 1, 2, 3, 4, 6, 12, and then we also had 1/2 and 3/2. And then we're going to go on to step 2. We're going to test possible roots until we find one that is an actual root. We're going to use synthetic division. If the remainder is 0, then we know we found a root. So we're going to test. Now here's an important thing to know, and that is that if you tested one before and it didn't work, it's still not going to work. So the ones that you already tested that did not work still will not work. Since we already tested 1 in the original function, we don't need to test 1 again. But we could still test -1 because it worked one time and it might have a multiplicity. So we'll test -1 and see if it works. So we have 2, 1, -12, -12. And we'll see if we get a remainder of 0. So 2 brings down, multiply times -1, so -2, add -1, multiply 1, add -11, multiply 12, 11 times 1 is actually 11, add -1. So this is not a root. So we'll go on and test something else. How about 2? 2, 1, -12, -12. So bring down, multiply, add, multiply, add, multiply, add. Okay, this is not a root. Let's try -2. -2, we go 2, 1, -12, -12. Okay, bring down, multiply, add, multiply, add, multiply, add. Okay, so -2 is a root. So I can add to my list of roots -2. And then I'm on to step 3, which is to rewrite. So I will rewrite my function, f of x equals. I have the x plus 1 that I factored out before, and now I have x equals -2, which gives me the factor x plus 2. So I have times x plus 2, and then times the quotient row. So I have my constant term, x squared term. So 2x squared minus 3x minus 6. Now this is what I was telling you in that step 4, that we're going to repeat steps 1 through 3 until the quotient is quadratic. So since this is quadratic, meaning it has a degree of 2, we will use the quadratic formula or factor to find the last 2 roots. And then we'll be done because we were looking for 4 at the beginning of our problem. So I'm going to take that 2x squared minus 3x minus 6 equals 0, and if it factors, I would try and factor it. This one doesn't, so we will use a quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. So x equals 3 plus or minus the square root of, this makes 9 plus 48, so the square root of 57 divided by 4. Now 57 won't break down, so my last 2 roots are going to be 3 plus the square root of 57 divided by 4 and 3 minus the square root of 57 divided by 4.